Hi, welcome to the video on data mining classification. And if you remember from the previous video when we talked about classification, basically it's a method where we're trying to take a set of data and come up with a way of trying to classify based upon attributes of the data, try and come up with a way of figuring out what class it belongs into. Okay, we're trying to do a prediction here. We're trying to find what particular class. And the goal is ultimately, once we've been able to do that, we've developed a model, we then can take other records that we don't really know what class they're supposed to be in, and then try and predict what class they will be in as accurately as possible. And classification models can be used for things like trying to figure out how good somebody's credit is. It can be used in all sorts of different, will they be interested in buying a certain product in a product line, and the case that we'll be looking at from the chapter 10 in uh, the book from Rapid Miner is going to be looking at when should we be placing some marketing. So in classification, we're going to there's lots of different algorithms out there, but we're going to be using and looking at decision trees. And the analogy of a tree is used for describing this technique. It's simply a way of classifying based on a structure that starts at one point and then has branches, and each branch then can have branches until there are no more branches. And it's sort of a algorithm that's the people in computing field use these trees, and a decision tree is simply nothing more than there's one starting point and there's a path. Basically you go down one path, and the branches, what branch you go at each point where you split, there's a rule. And an example of this would be, if we were looking at, is this person a low risk or a high risk? We might have the first thing we're going to look at is age, and if they're greater than 21 years, we would then check their income. If they're below 21 years, we might think that they're high risk. Now, this particular decision tree might be for are they going to be compliant and following rules on driving on the highway, and so are they a high risk or a low risk? Okay, and then if they are greater than 21, well then we come to another attribute that we might look at as income. And if you notice here, in some cases we only have to look at one attribute and we're done. In some cases we look at multiple attributes. Here we look at the income and we look at was their income greater than 30K a year or less than 30K a year, and then if it's greater than 30K a year, we look at their education. And by the time we get down to these last leaves, they're called, but the end point where we basically have classified them. It's really what decision trees are about, and they're fairly easy to follow when they're relatively small. And so the interpretation is easy, okay? But they can become quite complex, and we'll see that when we look at the problem from the chapter. And do keep in mind that they are simply one way that classification, and we're only looking at one particular modeling approach for classification here. There are other approaches. If you think about it, it is pretty linear in how it gets applied, and you can think about that there may be other types of approaches might have feedback loops, and there's all sorts of other techniques, some of which are actually built into Rapid Miner. But we're looking at the decision tree here because it is fairly straightforward, and most people have seen decision trees. And my objective here is that you're going to learn everything about how to do complete classification, but rather you understand what classification is about. And so, the remainder of this video is going to show you using Rapid Miner the development of decision tree from chapter 10. And you really probably should read the chapter ahead of time or read it and follow as you go along. I do apologize. This video is fairly long, and so you might want to break it up. It's probably going to end up being close to a half an hour. So I do hope you enjoy it, though, because I think it is kind of fun to actually start getting you to use some of the technology. And if you have problems, email me, okay? I realize there's a quality diversity in the class in terms of the skill level. Some of you are in the technology field, and it's going to be very simple. Some of you are going to be sort of threatened by this. But, if you have questions, give it an honest attempt, read the chapter, look at the video. But if you need to, give me a call. Okay, if you go to the URL on page 29 of the chapter 3, I believe it's in, you get the location for where the files are for chapter 10 for the decision tree. And I'm just going to download them here and put them someplace where I can find them later, probably my desktop, since that seems to be the place where I can put a bunch of stuff. And then I don't know about you, but sometimes my desktop gets overly crowded, and then I simply create a folder saying clean up and put everything on my desktop into that folder and force myself to sort of go through on a Friday afternoon type of activity and clean it up. But there are two files here because there's a training set and then there's a set for that we actually want to score. And so we're simply going to download them. They're both now on our desktop, and now they're in a position where we can now go ahead and get out of the web browser here, and we can go into take a look at the files, and you'll see that they are comma separated files, and you can open them up in Excel. And there's two files. The only difference really between the two files is the order of the columns or the attributes vary a little bit, but this first file and second file are identical, with the exception that the second file has an additional column basically stating whether or not they were on the very end there, whether or not they were an early adopter or a late adopter, or basically what stage they were of the 4 stages. And so you can take a look at the data if you want ahead of time, but you're going to be seeing the data again in RapidMiner. So, and since RapidMiner is where we want to take a look at, let's jump into it. We're going to create a new process here, and one of the things we're going to want to do is create for ourselves a repository, a local repository, if you didn't already do that. And we do that by coming over here and clicking on the leftmost column here under repositories, and we can then come through here and create a new local repository, click on next, and from there we then will be able to enter in the name of our repository, and I'm just simply going to go ahead and call this, what should I call it? Local data. I know, not very original. But anyways, go ahead and click finish here, and we now see that over here on the left we have the local data listed, but our data still is in it. It's just we've defined effectively a local database, a local storage area where we can get files from that we actually are going to use in our modeling. And so we now want to actually import them, and so we come over to the next icon here, and if you click on the little arrow there, you can see that there's an import CSV file. We have to go back and point to the folder that our desktop, because that's where we stored our information. And so if I click on the double click here, I guess I better do. And I want to bring in the two data sets. I'm going to start with the scoring one, and I click on next. And the first thing you notice is we see the data in the comma delimited, but it actually defaults assuming that we were using a semicolon to separate data rather than a comma. You notice the minute we click on the radio button for comma, it starts looking a lot more like we saw it in Excel. And so we can go ahead and it says there's 5 steps, but there's not a lot to do. In here we have the ability, we can add some naming attributes for them. We're not going to, but the thing to note here is that it actually does try and identify for us, because of using the first column we got the attribute field, but it does go through and try and figure out what type of data we have. And so it looked at, for example, our user ID, which is, it went through and figured out it was integers, and so it assumes the data was integer. And it also went through and figured out for gender there were only 2 values, so it says it's binomial. And for each of the attributes, it's gone through and scanned our data and tried to classify it for us. Now we can actually override that, and we could actually say not to bring in some data by clicking here or unclicking. We're going to go ahead and bring in the data so I'm consistent with what's in the chapter. But the user ID is actually sort of a random number that we aren't going to really want to have, and we'll see that later on we'll remove it. But we can go ahead and click next, and now it asks us for give our a name, and since this is related to chapter 10, and this is my scoring data, I'm going to say scoring chapter 10. Okay, you can click Finish here, and you'll notice when I click on the Finish here is we have, it shows in our local repository the data that's there, and so we can see that we have now our a local file. We can go ahead and import the other file. Obviously, we can do this a lot quicker because I'm be redundantly saying the same thing over again. So I'm just going to click through here and get the data out there. So this time I'll give it the name for training, chapter 10. And so once we've done that, we've got our two sets there ready to be able to now use, and we can start developing our decision tree model in RapidMiner. So let's take a look, and we want to get back to the model, and so we need to click on that appropriate icon. Okay, now that we have the training sets and the scoring set into our local data, we can actually just drag them into the main process here, and by holding the mouse down and dragging it and releasing it. And if you notice, there's this little out node here. We take that and we bring it over here to the results, and if it connects, okay, we'll see that a new one pops up here, and we connect our lower one. There actually is a way you can set it up here to have it auto wire the operators. There's some advantages to that, and I can argue both ways which way to do it. I prefer to manually do it because that way I can make sure things are being done in the sequence I want. And so now that we've done this, if we want to take a quick look at the data here, we can hit our run triangle here, and you'll see that when we get our results, we have two example sets. One's our scoring and one's our training. And in our training set, we have one additional attribute, which is the e-reader adaptation, where they relate to either innovator based upon, you'll see in the chapter, basically what we're trying to classify for. Okay. In both of these, we have the data, we can look at data, but we can also click on this radio button here for metadata view. And in there, we can see for each of our attributes, it'll tell us what type it thought it was, but it gives us some summary statistics here, like the average or the mode, and sometimes the maximum min value, the ranges here. It can be a little bit helpful sometimes taking a glance at those to see what actually is in your data. But pretty much that's it to get the data in. So once we have the data in, what do we want to do next? Well, it turns out that if you remember when we imported the data, we sort of defined, we left all the fields define themselves to attributes. Well, there's a couple fields in here that really are not attributes, and that is basically the ID. Okay, and so we can come up here to operators, and if you type in set role, okay, we can drag that over here, and you'll see that as I drag this over here, the one thing that you will see is that little red line there, which is an indicator that there's an error. And that error is because even though I set this in here, it didn't really automatically do it. And here's where the case comes. If I go rewire here, you'll notice it automatically rewired these, and it's now connected. Alternatively, and let me do this, bring another one in here, and I bring this one over. You can just simply take and I'm going to make this the bottom one because I want to keep them in the right order, and I'm going to delete this one. I'm going to try and delete this one. Right click, disconnect port, okay, and from this output into the input port there for the example set. And so we still have the same data, but the difference is we have our training data and our scoring data. But the role, if we come over here now, click on the role, we're taking all the data and we're giving it to this function called set role. And it's pretty much, that's the way this thing goes, is we're passing data from one function or role to another. And when we come into set role here, we're going to simply say take the attribute that is called user ID, and instead of making that just a regular type of item, let's make that an ID. So it's not going to actually be used when we try and do our decision tree and create our decision tree. We want to do the same thing here in our scoring data set. We're going to come and make that same field our user ID. We're going to go ahead and make that an ID field. Now, in addition to that, we're going to bring over another set role because there's another, in our training set, there's one more thing we want to do. Now remember, we got that red line there because I did, and again, I can come up here, but I can come here and I can manually do it. Okay, and that's sort of mentally for me, it helps me to know, I'm coming from this, the result of this is becoming the input of this. So I go from this set role to this set role. Well, what do I want to do in the second set role here to the data? Well, we have the attribute. We need to tell, ultimately, our decision tree what we're trying to classify on. And so I want to go down to the e-reader adapter, and I want to select that attribute. And I basically want to identify it as our label that we're looking for. Okay. And so now, if we went ahead and ran this, we're not going to do the decision tree yet, but we can run this and we can see that we still have our data. And the difference is if we go over to the metadata view, user ID here, the role it's playing is now an ID. And in our other data set, if we look at the metadata, again it's an ID, but our e-reader adoption field is now shown as a label. So now we have our data, and we're pretty much got the data in, and we've sort of modified it for the way we want to be able to use it. So now let's go ahead and take the next step and bring our decision tree in. Okay. So we want to come over to our search box here for our operator, and we're going to type in decision tree. Okay, and we're going to take just the decision tree here, and we're just going to drag that operator over here and drop it in and move it over here a little. Now, if you noticed, it did connect this time, and if you notice the line, it actually became a little bit smaller. I'm going to click down here because I sort of want to drag this line so that it's clear that this line is not part of that, and maybe it'd be easier if I bring this over like this. I just want you to be aware, as we look at this data is not being involved with the decision tree. When we come to the decision tree, and we take a look, we can click on it here, and just like we had with set role, there's properties and things that can be set here. If you ever want to know what more information is about, under help, you can always get more information. This will take us through. In fact, you can look at the criterion for each one, and it'll give you some information about them. However, we're going to start off with just letting it take the default values here. Okay, and there's a scroll bar here because there's multiple keyhole, but we're just going to go ahead and run this. And when we run it, we see that we now have an example. Our example set, we have here a decision tree. And we now have a decision tree generated for us, and it basically is telling us how it's trying to define based upon a piece of information. And so we have here, okay, if a person is frequent, based upon their website activity being the first criteria, we're going to end up going down this branch for if they're frequent, we're basically going to say that they are going to be an innovator. Now, if you notice down here, this little box here is colored because ultimately, based upon, not everybody who's frequent is going to be an innovator. In fact, if you hold the mouse there, you can see that there was 54 who are in our training data set, and of those, 4 were late majority, 23 were innovators, 19 were early adapters, and 8 were early majority. And the innovator is this little yellow line here. And so, but based upon the default rule that we had, this is the best um, it's going to classify. Now remember those parameters, there's lots of ways we can interpret the parameters and do things slightly differently. Um, and we'll come back and talk about that briefly. But you can see here, it generates something fairly quickly for us in terms of a first pass of our decision tree. And the other website activity, if they're regular, they're viewed as an early adapter. And it's really only the people that are seldom that we even want to, the decision tree decided that we have to look at other types of information, such as whether they bought digital books, and if they still came to its website but they bought digital books, then they were basically going to be an early adapter. Otherwise, if they didn't, it depended upon their age, and if they were over 25 and a half, they're going to be part of the late majority. Otherwise, if they're under 25 and a half, they're considered to be part of the early majority. And you can see that in all of these cases, the classification is not 100% perfect. It shows us here, for example, the early majority. There are 36 cases that, or 30, the size of the number of people that would meet that path would be 36, but in reality, from our training set, 3 of those were late majorities. 1 was an innovator, and 32 were early majorities. So, 32 out of 36 isn't bad for just this. And so, one of the things that you have to ask yourself is how valid is the decision tree? Okay. But this has now given us, though, a basic decision tree. But one of the questions we sort of want to have is, well, can I get some values that sort of help me identify, is this, how accurate is this predicting? Is this worth using or not? And so in order to do that, we need to do another step. Okay, before we take a look at how we can sort of get a way of validating this data, and I should mention that this is not shown in the chapter, this next section of what I'm going to do here. But let's quickly run it one more time. And what I want to basically do is get a screenshot here that we're going to capture what this tree looks like so that we can look at it later. Now it turns out if I come over here and I can actually print my decision tree, or I can actually export that decision tree to a PDF document, and I'm going to go ahead and do that. I'll go ahead and put that on my desktop and clutter my desktop. Original tree, and go ahead and hit save. Okay. That's simply because I want us to be able to come back and look at this again. But we should ask ourselves, how valid is the model? And so if we come back over here, it turns out that so far I've let us follow the way that the chapter had set things up. But actually, if I was going to do this decision tree, I would have set it up a little bit differently, because we're really going to need to split our data. Our scoring data that we're going to show how we can score the data after we've developed our model. Well, in order to validate the model, we have to know what the right results are. So we actually have to take that training set and split it into 2 separate parts. The part that we developed the model from, and the part we validated from. So for right now, I'm going to come up here and I'm going to delete this decision tree. Instead, I'm going to come over here and I'm going to type in my operator validation, and we see that we have this operator here for split validation. I'm going to bring that over and put it in right here, and I'm going to go ahead and take my data and connect it here, and I'm going to connect my model out here. Okay. Now, it turns out we're not really going to be using this down here right now for a minute or two, but don't worry about that. Now, you'll notice we have a little red dot here indicating we have an error, and that's because all I've done here in validation is I'm saying I'm going to split the data, and you'll notice those parameters are used. This basically says 70% of the data is going to be used to create the model. I could change it to 0.5 being half the data. We could do it however we want. We have different ways of sampling the data. We can basically change the random seeds. So every time we run, we get a different random seed. And we can split it in different ways. And so our sampling here is sort of a shuffled. We could try and do a more stratified sampling, but we're just going to let it be random for right now. This validation just simply says we're going to take a data set and split it into two pieces. And so 70% for the model, 30% for validation is what we're going to leave it at. And you click on this box down here, and this takes us to a sub-process. And this is a process that's going to be taking place in the validation. And so it's broken down in here to the training and testing. Well, what did we do for training? Well, what do we, we're training and creating a decision tree. So this is where we're going to put our decision tree back in. And we're going to go ahead and click Decision Tree and look up our training set here and bring our model over here. Okay. And then we actually want to apply the data to our model that we developed with the rest of the data. And so let's go ahead and type in apply model. And we're going to drag that operator over here under testing. Okay, and I can bring the mod to the mod, and then my test data into my process here. Now, all I've done here is I've created the decision tree just like we did before. If I click on here, we have the same parameters as before. We haven't actually changed any of those parameters or looked at them. But over here, we have our applied the model. Well, there's still one more piece we want to actually get. Well, we've done this validation. We still need to somehow measure the performance. So I'm going to put in an operator for doing the calculations for performance for us, and just type in performance. And you'll notice that there's action operator for performance for classification. And I'm going to drag that over here and place that down. And so now I'm going to connect here my label data, and I'm going to collect here my average. Okay, and you'll see, that we have yellow lights here. We don't have any red lights, so it doesn't look like we have any errors. Well, you might say, how do I get back to my original model? Well, up here we have we're in a sub process. We're in that process that we decided to have split the data and have some of it go through training, and then the model as a result go through the test data. Notice the TRE for the training part of the data is coming in. Over here, the model itself is being passed to the model, and the test data is coming into the applied model. When we click on this arrow, it brings us back up here, and the one step we have left is we still want to get the numbers, and so let's go ahead and take our average results from the model and click on the right node here, and let's try that again. Hit the escape key there and come over here, and one more time, and connect. Okay, now we can go ahead and run our model, and we'll see that when we get done running, there's a tab here for the performance vector. And in here, you can see first of all, the overall accuracy is 53 and some change, percentage correct. Now, is that a bad accuracy or not? Well, given the business problem that this case is for, that might be acceptable. And that's a decision that the user sort of has to figure out what is acceptable or not, or to some extent the analyst, is their model valid enough or not? And so it can be, sometimes the decision can be made by the modeler, sometimes by the end user. And there's lots of different ways to try and measure accuracy. In fact, accuracy is just sort of a global measure here. You can see here actually the numbers that in terms of, we predicted it was a late majority, and it turned out that if we looked at the ones that were late majority, 45 that were late majority were actually predicted to be late majority. But we also had one, and this takes all that summary data that you saw earlier when you look at the decision tree, but it brings it into a table here and gives us some percentages. And so here, the percentage of the time that class, within that class that we accurately predicted, and uh, likewise the inverse by looking at the rows and the columns. And so that gives us some feel. So now if we went and change one of the parameters, for example, how we did our decision tree, let's just use the global parameter for right now, 53.54. And let's come back to our model. And let's come over to in here and double click that. Come down to the decision tree and let's change our criteria here from gain ratio to what the chapter talks about is what happens if we change it to the Gini index. And we're going to go ahead and run this, and takes a bit here. And you'll notice our accuracy now jumped up to 59.6%. And so you can see how there's different parameters that can be tweaked with the model. In this class, we're not going to become experts in each of these model techniques. My objective here is more to expose you to the different types of models that are out there. Well, what happens if I actually wanted to use that model? You might say, so let's go back and do that last piece. And so we're going to sort of come back here to our model, and instead of in our model here, because we have validation in the chapter, this looks more, this is where the decision tree comes out, but we should be able to still go ahead and apply our model. So let's do that. Before we do that, though, there's one thing that we should quickly take another look at is, wait a minute, the accuracy went up. That should have some, you might say, how did that happen? And it turns out if we go to the decision tree and look at the decision tree has gotten much more complicated. And so let's try and zoom this so that we can see the whole tree at once. Show view, and apparently I am doing it. And you can see that our tree before that was nice and simple now has become much more complex. Okay, and does that mean that the tree is not useful? Well, again, you have to look at sort of the business application of the tree. If you're going to expect somebody to follow this tree manually, it could be a little bit of a problem. However, if these are just simple rules that you follow down through the decision tree and they're automated, technology really doesn't complain too much about having to go through various steps. But you can see that the tree has gotten much bigger. Okay, and so in fact, I'm going to go ahead and export this tree as the PDF. Again, we'll put it at the desktop, and this time, revised tree. Okay, and I'm going to save that. All right, now that we've taken a quick look at the tree, now let's come back and talk about how do we actually use the model if we were going to use it in this particular situation. So I can come to this set role here that we had before. And if you remember, how did we actually use the model in the validation? Okay, we had to use an operator called apply model, and we're basically going to use the same model, the same operator, apply model, and we're going to bring it over to here. Okay, and what do we want to do? Well, if you think about it, the data we want to be is our data that we have that we want to score, and the model now is the model that comes out of the validation. It's the same model. The model hasn't changed here. And now out of there, we can still put out, and let's move this over just a little bit here. We can go ahead and put out the labeled data that comes out. Okay. And we can show what our model is. Okay. So now if we go ahead and run this again, okay, again, it's the same. We're going to have the same decision tree, but now if we look at our the example set, and we sort of look at the various rows from our example, we had these 473, but if we go back to our model, okay, and we look at, how many items were we going to score? Okay, how many were in the set? Well, you may not have noticed, but if you hold this down here, we find there are 473 examples. So these indeed are the scoring set that came out. And so if you go back and look at that, we then can have some confidence that we're looking at the right information. And we can see that row one, the confidence factor for row one was, we had a 60% confidence factor that this person was an early adopter, okay, and that was the prediction, okay, and it tells us the prediction. Now, you can actually have a operator to export this file if you wanted to at this point. We have this ability here, and so we can actually store it in the repository, or we can actually, once in the repository, you can export it as an Excel spreadsheet or a common delimited file type of thing. And so you can see that we not only can build the model, but we can actually use the results then if we wanted to in another set. So that's a quick overview of the decision tree, and for your tea time exercise, I'm basically going to have you develop another decision tree on your own. And so I'm going to go to the activity and take a look at it, and I will see you. Hope you have fun with it, and then we'll go on to the next video after that. So I'll see you then.